Hi Year 10. This is the second of two lessons where I'm recapping some of the basic geometry that you need to know for the remainder of this chapter. This one is about congruence proofs. By the end of this lesson, you should be able to prove that two triangles are congruent and use congruent triangles to prove other things. And that's what this question asks us. The first part of it is to prove that triangle WXT is congruent to triangle VXT. So that's WXT and VXT, that those two half triangles are congruent. And then it asks you to prove that X is the midpoint of WV, so that this point here is right in the middle. You'll notice that the triangle doesn't have distances marked on it, so we can't just assume that this line, let me just grab my pen, can't just assume that that line is the same length as that line, because it's not drawn in. Okay, so when the diagram looks like that, you can't assume that X is the midpoint. We need to prove it. We're going to prove it by starting to prove that the two triangles are congruent. Look at the question. In the diagram on the right, angle W is equal to angle V. You see angle W and angle V. Those two angles are the same size. It says it there. It also says that TX is perpendicular to WV. TX is the vertical line there, and WV is the horizontal line at the base of the triangle. It's actually asking us to prove that triangle WXT, the left-hand triangle, is congruent to triangle VXT, that's the right-angle triangle, the right-hand triangle. Now, can you remember what the congruence proofs are? There are four of them. The first one is side, side, side. If we can show that three sides of two triangles are the same, two triangles have three sides the same, then they must be congruent to each other. They must be the same size and the same shape. It's also okay to show that side, angle, side. Two sides and the included angle are the same in both triangles. Or maybe angle, angle, side. That is, two angles and a corresponding side must be the same sizes. And the last one is right angle, hypotenuse, side. Those four tests are normally written in brackets because they're a shorthand way of saying what the three letters mean. Now, which one of those tests apply to the two triangles that we're interested in, WXT and VXT? Can you be sure that the three sides are the same? That two sides and an included angle are the same? We've got two angles and a corresponding side. Well, they're both right angled triangles. Have we got the right angle, the hypotenuse, and another side? We've got two angles. These two angles are the same. This one is a right angle, so that would mean that that one must be a right angle, because the lines are perpendicular. So have we got a corresponding side being the same in these two triangles? Can we use an angle-angle side proof? Well, we don't know that these two sides are the same. That's not given. We don't know that those two sides are the same. It's not given. And actually we're going to be asked to prove it over here. What are the other two sides in the triangles? Well, they share a side in common, TX. And since that side is shared by both triangles, it must be the same in both triangles. So I'm going to use an angle-angle side proof to prove that those two triangles are congruent. Let me scroll down a bit. Remember that every proof has 5 lines. You have to start with an introduction. You have to direct the attention of the person reading your proof to the triangles that you're interested in. So I'm going to write something obvious. I'm going to write in triangle WXT and triangle VXT. Okay, so I'm just really rewriting that, but using and in the word in. What I'm actually trying to do is just get people to think, the person who's reading my proof rather, to think about those two triangles. Now I know that I'm going to use an angle side proof. You don't normally write down angle side down the side of the page, but it's worth doing just when you're beginning, just to keep track of what you're trying to do. Okay, I want a line that tells me that two angles are the same in both of the two triangles that I'm interested in. Well, we've got it given to us that W and V are the same. So I'm going to say angle W is equal to angle V, and you need to say how you know that. Well, I know that because it's given. That's actually part of the question, which means that I've got my first angle line done. What other two angles can I use for the second angle line? Well, I know that TXW is a right angle. Those two lines are perpendicular. And I know that TXV is a right angle. Okay? Those two lines must be the same, or two angles must be the same, because this line, TX, is perpendicular to WV. It says so right there in the question. So let's write that down. I know that angle TXW is equal to angle T, let me get that right, is equal to angle TXV. In fact, I know that they're both equal to 90 degrees. And the reason that I know that they are both equal to each other, and they're both equal to 90 degrees, is that TX is perpendicular to WV. And I can write that because it says it in the question. Now, the only other thing that I need to show is that these two triangles have a side that is the same. The side we decided to use was TX. And the reason that we know it's the same is that it appears in both triangles. It's common to both triangles. So let's write that down. I'm going to say that the sign TX is common. Now, having done that, I've achieved what I wanted to achieve. I've shown that two angles and a corresponding side is the same. I know it's the corresponding side because it's the side that's opposite W and V in both triangles. Okay, so now I need to write my conclusion. Conclusions always start with the three little dots that tell you this is a therefore. I'm going to say therefore this. That's what I was setting out to prove. Therefore, triangle WXT is congruent to triangle VXT. Once I've got that done, I don't need my angle side markers anymore, so I'm going to rub them off because I want you guys to remember that those are not part of the proof. They're just what you need to know in order to start writing the proof down. Okay, so that was part A. In part B, I'm asked to show that will prove that X is the midpoint of WV. That X is the midpoint of that line. Now hang on, that line is made up of two sides of the triangles that we've just been looking at. The bottom side of triangle VXT and the bottom side of WXT. Now we've shown that those two triangles are congruent. And they're similar, they're corresponding sides in congruent triangles. Now, one of the things that we know about congruent triangles is that the sides are the same size, so that would mean that the sides WX must be equal to the side VX. Okay, so I can actually write down WX is equal to the side VX, and the reason that I know that is that corresponding sides in congruent triangles are equal. Corresponding sides in congruent triangles That means that X must be smack in the middle of WV. Therefore, X is the midpoint of WV, because it divides WV in half. And we're done.